Alright, welcome back. So in the last topic, we used an old rusty card to talk about chemical equations that show us what's happening during a chemical reaction, during a chemical change. We talked about our reactants on the left-hand side of the equation, turning into our products on the right-hand side of the equation. What I want to focus on more in today's topic is those coefficients telling us how many of each of the different atoms and molecules are taking place. I mean, if I said to you, iron is reacting with oxygen to make iron oxide, you could simply write the statement like this. There we are, iron metal Fe plus O2 oxygen gas making iron oxide Fe2O3. But there is a problem with this. It breaks a fundamental law of the universe. You cannot create matter and you cannot destroy matter. We're not magicians, we're chemists. So when you're building something, you need all of the pieces. If you don't need some of the pieces, they won't disappear into thin air. They have to go somewhere. What I'm talking about, we need to make sure our chemical equation is balanced, that the number of each atom we have going into it is the same as the number of each atom coming out of it. So let's explore how we do this. I'm going to explore it by using a simple chemical equation that we've already discussed quite a bit. So once again, this is the reaction between hydrogen and oxygen to make water. As currently presented, this equation isn't balanced. Now you might be tempted into thinking, well, there's 2 hydrogen and 2 oxygen on the left, so the easy way for me to fix this would simply be to pop a 2 there. And now I've got 2 oxygens on the right as well, everything's balanced. But we've broken a different law. This reaction is meant to be hydrogen and oxygen reacting to make water. But by changing that number down the bottom, what we've done is we've changed the molecular formula of this substance. Water is H2O. You've now got H2O2. That's not water anymore, that's hydrogen peroxide. Hydrogen peroxide is really nasty stuff. How's your quest for chemistry jokes going? 2 guys walk into a bar. First one orders a glass of H2O, second one orders a glass of H2O2, second one dies. Think about it. It's terrible, terrible. Anyway, let's go back to our chemical equation. So if this is what we're starting with, we cannot change the molecular formula. You cannot change the identity of any of these chemicals. All we can do is change the number of each of the different molecules that we have. We do that by putting coefficients out the front like so. So I now have 2 hydrogen molecules reacting with 1 oxygen molecule to make 2 water molecules. All of our atoms are balanced. I've got 4 hydrogen on the left, 4 on the right, and I've got 2 oxygen on the left, 2 oxygen on the right. This is now balanced and I haven't broken any rules. This is now water. So what we're going to do is we're going to go through a more involved example together. We're going to talk about how we balance these chemical equations and give a few bits of advice on how you can speed up the process and do it more efficiently. So I have an example here on your screen for you. I've got a reaction between aluminium nitrate and potassium sulfide to make aluminium sulfide and potassium nitrate. So here is our chemical equation. We're going to balance it. There's lots of different ways that people approach this. There's not necessarily a right and wrong place to start. There are 2 bits of advice that I've heard over the years I find to be useful. First of all, if you see an element, an atom that appears over and over in your chemical equation, don't handle that first, handle it last. Do anything else first. More general advice that I tend to give people, look to balance anything other than hydrogen and oxygen, because they're often the culprits that appear a lot. Then do your hydrogen and finish up with your oxygen. If you'll do that, more often than not, your balancing will tend to take care of itself. Let's have a look through this one now. The other thing I'm going to do is draw up a chart under this chemical equation. If you've got a complicated example, this chart will help you keep track of what you're doing. Simple examples, you might not even bother. What we're going to do in this chart is we're going to list each of the different atoms that we have. So Al, I've got aluminium. N, I've got nitrogen. O, I've got oxygen. K, I've got potassium. And S, I've got sulfur. We're then going to go through each side of the chemical equation and count how many of each element we have. So first of all, left-hand side, I've got 1 aluminium here, so 1 there. For the nitrogen, I have 1 per nitrate, but there are 3 nitrates. So that means I have 3 nitrogen there. For the oxygen, I have 3 lots of 3. 3 times 3 is 9. For the potassium, I have just the 2 potassium over here, so no problem there, 2. And for the sulfur, just the 1 on the end, 1. If we go through that same activity on the other side, for aluminium, I now have 2 aluminium here. I have 1 nitrogen over here on its own. There is. For oxygen, I have 3 here. For the potassium, just the 1 here. And for the sulfur, finally, I have 3 here as part of my aluminium sulfide. Right, so now we can see the state that our chemical equation is in. There's clearly a lot of different numbers on one side compared to the other, so time to start balancing. Remember, we can only do that using coefficients, and we do anything except for hydrogen and oxygen. So I'm going to start at the top of the list. Aluminium is clearly out of balance. I've only got 1 on the left and I've got 2 on the right. So to fix that, I'm going to place a 2 in front of my aluminium nitrate. That gives me 2 of everything that's there. So it's going to fix my aluminium problem. That's going to increase. That will now be 2. However, we've also changed the nitrogen and the oxygen because they are both part of this chemical equation too. So my nitrogen has now increased. Instead of having just 3, it's doubled. I now have 6. And the same with my oxygen. If I had 9 before, I will now have 3 times 3, which is 9. If I've got 2 of them, that's a total of 18. So that's the first change we've made here. Have a look at your table. What else is out of balance? Aluminium's fine at the top. The next one down the list, nitrogen, clearly out of balance. 6 on the left, 1 on the right. Okay, so to fix that, again, nice simple change I'm hoping, we put a 6 out the front. That will fix my nitrogen problem. It will change the potassium, the nitrogen, and the oxygen. So all 3 of these are going to change. The nitrogen will have now gone up to 6. The oxygen, 6 times 3. So you can see there's 3 oxygens per molecule and there are 6 of them. So that's come up to 18. I'm happy seeing that because I've got 18 on the left. And my potassium has also gone up to 6. That's that change done. When we look at our table, it's starting to look a lot better now. Moving right down to the bottom, potassium is the next one I've got that's out of line. 2 on the left, 6 on the right. So to fix that, I need to multiply that molecule, the potassium sulfide, by 3. That changes both my potassium and my sulfur. And again, if I add them up, for my potassium, I've now got 3 times 2, so that would be 6 potassium. And for the sulfur, I've now got 3 of them. And if you have a look at your table now, you'll see that on the left-hand and right-hand side, they are both identical. That means this equation is now balanced. That's exactly what we want. So, a quick recap of what we've done in this topic. We've had a closer look at chemical equations and the coefficients that we use in them, discussed the idea that we cannot create or destroy matter, that the atoms that go into a reaction have to add up and they have to come out, so we balance our chemical equations. We do that using those coefficients to make sure that the number of each element on both sides is the same. When you're balancing, my advice, leave hydrogen and oxygen alone, do everything else first, and then balance them last if you need to. If you do that, things should work out pretty well. Make sure you're comfortable with that. When we move on to the next topic, we're going to start exploring some of these different types of chemical reactions.